We want to find the complex number z that satisfies this equation and this equation. With the locus of z for this particular equation is actually a perpendicular bisector. If I were to re-express this, z minus of 6i is equal to modulus of z minus of minus 10 minus 4i. It is going to be a perpendicular bisector of 2 points. One of the points is at 0 and 6, and the other point it is going to be at minus 10 and minus 4. And its perpendicular bisector, where its perpendicular bisector is going to cut the circle at 2 points, and what we are supposed to do is to find the z of these 2 points. There are actually two possible methods that I can find the z of this. One is to use a geometrical method, which I'm going to show you later, because what I'm going to do now is to try to form the Cartesian equation of the circle and the Cartesian equation of this line and just solve the simultaneous equation. If you think about it, this is actually a slightly longer method, but it requires less analysis, and it is actually better, right? When we are under exam kind of condition, because during exam, there are a bit more stress and with time constraint. So this is probably my go-to method because it doesn't actually compromise on the precision that we are looking for. Let me show you how that can be done. First, let's form the equation, the Cartesian equation for the circle, where the circle has a center at minus 5, 1 and a radius of 4. So the Cartesian equation of that circle will be x minus the x coordinate of the center, so x plus 5 square, plus y minus the y coordinates of the center, so this square is equal to the radius square. So 4 square, this is equal to 16. This will be my first equation. For the second equation, is going to be the equation of this perpendicular bisector. If I were to call this, let's say, m, that means the coordinates of m is going to be this plus this. The x coordinate will be minus 10 plus 0 divided by 2. So minus 10 plus 0 divided by 2. And the y coordinate will be minus 4 plus 6 divided by 2. This tells me that m is at minus 5 and 1. In fact, it is the same point as the center of the circle. But anyway, this is going to be the point that is lying on this perpendicular bisector. I'm going to also find the gradient between these 2 points, which can help me to deduce the gradient of the perpendicular bisector. If I were to call this point, let's say this point, let's say I'll call it A, and this point I'll call it B. That means the gradient of AB is going to be equal to 6 minus away minus 4 divided by 0 minus away minus 10, and this is going to be equal to 1, which means that the gradient of the perpendicular bisector is going to be minus 1. So I'm going to try to form the Cartesian equation of the perpendicular bisector, and that is going to be y minus the y coordinate of m, y minus 1 is equal to the gradient, which is minus 1 over this, so minus 1, multiplied by x minus the x coordinate of the midpoint, so x plus 5. And this is going to get me a y is equal to minus x minus 4, and this will form for me my second equation. So equation 1, equation 2, I'm going to just solve the simultaneous equation, and that will give me the complex number that satisfies both that equation and this equation. I'm going to sub this into here. So plugging equation number 2 into equation number 1, what I'll have is x plus 5 square plus y is minus x minus 4, then minus 1 square, this is equal to 16. This is x plus 5 square plus minus x minus 5 square is equal to 16. In fact, minus x minus 5 square, I can rewrite that as just simply x plus 5 square also, which means that what I have here is going to be 2 times of x plus 5 square is equal to 16. So x plus 5 square is going to be equal to 16 divided by 2, 8. So x plus 5 is going to be equal to plus or minus square root of 8, and x is going to be equal to minus 5. Square root of 8 is square root of 4 times 2, so it is plus or minus 2 square root of 2. I'm going to try to solve for the y coordinate. I'm going to substitute into here. So Let's say when x is equal to minus 5 minus 2 square root of 2, substituting into here, I'm going to get y to be equal to, replacing x by this, it is going to be 5 plus 2 square root of 2 minus 4. This is 1 plus 2 square root of 2. And when x is equal to minus 5 plus 2 square root of 2, y is going to be equal to, substituting into here, it is going to be 5 minus away 2 square root of 2 minus 4. It is 1 minus 2 square root of 2. That is why the z that is going to satisfy both that equation and that equation, where it is going to be that z, right? Okay, the first z is going to be minus 5 minus 2 square root of 2 as the real portion. So minus 5 minus 2 square root of 2. And when it is minus 5 minus 2 square root of 2, the y is 1 plus 2 square root of 2. So it is this plus I of 1 plus 2 square root of 2. And the other possible z that is going to satisfy this two equation is going to be when x is, the real portion is minus 5 plus 2 square root of 2. So minus 5 plus 2 square root of 2 plus I of 1 minus 2 square root of 2. So 1 minus 2 square root of 2.